This is a question from AQA A-level Chemistry. It is from paper 3. It's required practical assessment, and this one is based on RPA6. I'm going to recommend you pause and have a go for yourself before reviewing the answers. So let's start by looking at parts A, B, C, and D. And finally, we've got here parts E and F. So let's take a look at them. We have got here a question about structural isomers P, Q, R, S, T and U. Identify the isomers that would react when warmed with acidified potassium dichromate 6. State the expected observation. So you've got to get all of the isomers. It does say multiple. And if we take a look through them, acidified potassium dichromate 6 can oxidize primary alcohols and secondary alcohols and aldehydes actually, but it cannot oxidize tertiary alcohols or ketones. So P is actually a tertiary alcohol based on skeletal formula, so would not, but Q would. We'd be able to make an aldehyde. With R, we are going to get a ketone. With S, we are going to make a ketone. And with T, we could make a carboxylic acid. So you need all four of those to get that first mark. The expected observation with acidified potassium dichromate 6 is that it will change from an orange to a green solution. For part B, identify the isomer or isomers that would react with Tollens reagent. Again, this has got to be exact if there's more than one. What would be the expected observation with Tollens reagent? Well, actually, in this case, there is only one aldehyde. So we're looking for T. And with Tollens reagent, you've got to remember the observation is that we would form a silver mirror. Moving on to part C, we have got separate samples of each isomer warmed with ethanoic acid and a few drops of conch sulfuric. In each case, the mixture is poured into a solution of sodium hydrogen carbonate. What isomers would react with ethanoic acid? What would be a simple way to detect if the reaction had taken place? And give a reason why the mixture is poured into sodium hydrogen carbonate solution. Well, what I'm hoping that you've spotted here is that we're dealing with esterification. We've got our conch acid catalyst and we've got a carboxylic acid. So for this, we're looking at alcohols that would be able to undergo esterification. So for here, we have got P, Q, R and S. Again, all four of them are needed. The simplest way of checking if an ester has been made is that you will get that sweet ester smell. Don't need to do anything other than check for that smell. And the reason that we add it to the sodium hydrogen carbonate is because we had that concentrated acid catalyst and this will neutralize that catalyst. Moving on to part D, what type of isomerism is shown in P, Q, R and S? They are all positional isomers. So we move on to parts E and F, and we've got here some organic structural determination analysis. Describe fully how the infrared spectra can be used to distinguish between R, S and T. And remember, you do have all of this provided in your data booklet. Now, for R and S, they are alcohols. So we are going to get an OH peak between 3230 and 3550. Whereas T is a carbonyl. It hasn't got an OH. We won't have that peak at 3230 to 3550, but we will have that really sharp defined peak at 1680 to 1750. At this point, we've now identified which is T, but it hasn't helped us separate R and S. So for R and S, we can look at the fingerprint region. Each of them will have a unique fingerprint region below 1500 cm to the -1. And what do we do when we look at that unique fingerprint region? We consider the known database of fingerprint regions. We compare against that database, and that will allow us to correctly identify R and S. In terms of F, why would electrospray ionisation not be a suitable method to distinguish? Well, actually, it might be worth going back and checking on this so you can see it. They've all got the same MR. They'll all have the same molecular ion peak. For that reason, it would not help us to distinguish at all. That takes us to the end of this question. Thank you for listening and goodbye.